So we're going to compare the left ventricular pressure curve to that of the atrial tracing. And when we do, this is what we have. Let's do the same thing over and over again. You like it now? I hope so. So what you'll find is the following. On the left is, once again, your left ventricular pressure curve. And what are you going to compare this to? Not the aortic pressure. This is the atrial tracing. In the atrial tracing, A wave. Quickly tell me what happens. It's the P wave. Bam. SA node. Followed by mechanical contraction. That's my A wave. What part of my cardiac cycle am I in? Late diastole. Late diastole, not systole. Be careful. Next, I form a C wave, but the C wave is only 50% of the time, technically speaking, bulging of the cusps. Use the C to help you into the atria. Let it go. Now we have our issue. As the blood, remember, mitral regurg, think in your head what's happening here. What kind of flow from left ventricle? Bidirectional. Bidirectional. One over here to the aorta, one over here to the left atrium. During systole, what should be happening? During systole, it's the fact that the left atrium is being filled up by pulmonary veins. In addition, now, blood is also coming from left ventricle. Acutely, what did we say happened? Acutely, the left atrium is not accustomed to that type of volume. So what about the pressure? Ridiculously high. Would you tell me normally, close your eyes, you tell me normally, what does that V wave represent? The V wave represents, during systole, the fullest that the left atrium, or right atrium, in this case the left, is going to then fill up with blood, right? That's what it is normally. All of a sudden now, blood is also coming from left ventricle. And acutely, that pressure is going to be acutely high. Hence, the huge V wave that you're seeing on the solid red line on the left graph. Over a period of time, what will the left atrium do? It'll learn to adapt to that high volume. Thus, what happens to its pressure? It's going to come back to normal, but what's the size of my left atrium? Increased. So which one's chronic? The dash line that you're seeing, the red line, the dash red line on your left curve. Now, in terms of your murmur, there's S1. What does that represent? It represents closure. Is that where my problem is in MR? Yes. It doesn't want to close. It begins right after S1. It passes through S1, let up, dut up, let up, dut up. My murmur is holosystolic all through S1 and S2. What was the other systolic murmur that you and we have seen together? Aortic stenosis. It was a diamond in the middle, a crescendo decrescendo. That was aortic stenosis. Let's take a look at a pressure volume loop. What's the most important point here? Well, I want you to take a look at, number one, the loops. Now, what chamber is the loop? The pressure volume loop is only left ventricle, period. And what's the x-axis mean to you? It is the volume. So now you have all this blood in your left atrium. During diastole, it's filling up the left ventricle. What's the size of my left ventricle? Huge. The opposite of mitral stenosis. Stay with me. Now, since the size of the left ventricle has enlarged, which way is that loop going to move? To the right. You see that? That entire blue loop that you're seeing is to the right. But Dr. Raj, that is the weirdest looking loop that I've ever seen in my entire physiologic life. And you're absolutely right, because it's pathology. It's a mitral regurgitation. So where's my problem? My problem is, you see curve green B. There's my problem. Normally, what should that be? You see that red line? That red line on a pressure volume loop is an isovolumetric contraction. It should be nice and vertical, man. You've lost it. You've lost it because during mitral regurg, you've lost the ability to create a proper isovolumetric contraction. During isovolumetric contraction, what is actually happening? Blood is leaving left ventricle and going into left atrium, is it not? Are you picturing this? And so therefore, you're not able to form a proper straight vertical line. You form a deficiency of isovolumetric contraction. You find that on your pressure volume loop, without a doubt, your diagnosis mitral regurg. All they have to show you on any of your exams is, you see where it says A on that right graph? That A represents the loss or deficiency of your isovolumetric contraction. Welcome, ladies and gentlemen, to MR mitral regurg.